I'm Angelo Caltan, and today I will discuss three problems from Chapter 15 of Physics. Problem 15.1. The speed of sound in air at 20 degrees Celsius is 344 meters per second. A. What is the wavelength of a sound wave with a frequency of 784 Hz, corresponding to the G5 on a piano, and how many milliseconds does each vibration take? B. What is the wavelength of a sound wave one octave higher or twice the frequency than the note in part A? So, wavelength is equal to velocity over frequency. This will give us 0.4338. Each vibration on this note is 1.2755 milliseconds. B. What is the wavelength of a sound wave one octave higher or twice the frequency? So, wavelength equals V over 2F. This will give us 0.2194 meters for our wavelength. Problem 15.6. A fisherman notices that his boat is moving up and down periodically, owing to the waves on the surface of the water. It takes 3.0 seconds for the boat to travel from its highest point to its lowest, a total distance of 0.69 meters. The fisherman sees that the wave crests are spaced 0.8 meters apart. A. How fast are the waves traveling? B. What is the amplitude of each wave? And C. If the total vertical distance traveled by the boat were 0.35 meters but the other data remained the same, how would the answers to parts A and B change? So, A. Speed is wavelength over period. We will double the period since it's only the time it takes for the boat to travel from its highest point to its lowest, not highest point to its highest point, which is crest to crest. That is the measurement of period. So it will be 8 meters over 6 seconds. This will give us 1.3 meters per second. A. For A, the amplitude equals the change in y divided by 2. This is just 0.69 meters, the distance from its highest point to its lowest divided by 2, since amplitude is the distance from the middle to its highest point or from the middle to its lowest point. So C, if the total vertical distance traveled by the boat were 0.35 meters, how would the answers to parts A and B change? So horizontal speed will remain the same, but the amplitude will become 0.175 meters. Problem 15.19. A thin 71 centimeter wire has a mass of 16.5 grams. One end is tied to a nail and the other is attached to a screw that can be adjusted to vary the tension of the wire. A. To what tension must you adjust the screw so that the transverse wave of wavelength 3.4 cm makes 876 vibrations per second? B. How fast would this wave travel? So in solving this problem, I got the velocity first using velocity equals frequency times wavelength. This gave me the velocity 29.784 meters per second. And then, to get the tension or the force, I used the formula force equals velocity squared times mass per length. And this gave me the value 20.62 newtons as the tension to make these properties possible. So thank you for listening and I hope you learned something from my presentation.